Okay, so let's look at how we decompose with quadratic factors. Okay, so we would have a linear numerator. I don't know why it does that. Over x squared plus 9, and then we'll need cx plus d over x squared plus 9 quantity squared. Okay, so multiplying by our common denominator of x squared plus 9 quantity squared, x squared minus x plus 9 equals ax plus b times 1x squared plus 9, and then it clears the last one completely, so plus cx plus d. Okay, so not a problem, but unlike linear factors, we can't get the zero of x squared plus 9. So one very useful method, let's expand these factors. So it would give me ax cubed plus 9ax plus bx squared plus 9b, and then I have my cx and my d. So on the right hand side, I'm going to collect according to the power, so nothing to combine x cubed or x squared, but notice I have an x in both of those terms, so I can factor that out to 9a plus c. And then I have my constant terms, 9b plus d. Okay, so now from here I can equate coefficients. So using the equation on the left-hand side, there's no x squared, x cubed term, so 0x cubed would equal ax cubed, so a is just equal to 0. For my squared term, I have 1x squared is equal to bx squared, so that makes 1 equal to b. For my x's, my coefficient to the x is -1, so I have -1 equals 9a plus c. Using the fact that a is equal to 0, -1 is equal to c. And then lastly, 9 equals 9b plus d, because 9b plus d are my two constant terms. So plugging in my value for b, I also get d to equal 0. So these end up working very nicely for us. So it'll eliminate a and d here. On the next screen, I'm going to rewrite this. So I'm left with the antiderivative of 1 over x squared plus 9 plus the antiderivative of -x all over x squared plus 9 quantity squared. So once I decompose them, now my first antiderivative, this is my arctan. A is equal to 3, u is equal to x. So I have 1/3 arctan of x over 3. For my second integrand, I'll do a u substitution. U is equal to x squared plus 9. Du is equal to 2x dx. So I'll bring a -1/2 out front, u to the -2nd. So arctan of x over 3, that's finished. And then it'll be -1/2 times u to the -1 over -1. So my last substitution, arctan of x over 3 plus 1 over 2 times x squared plus 9 plus c. So quadratic isn't difficult at all. It just takes that extra step of multiplying these out. And then again, the method of equating coefficients really saves you a lot of time. All right, and the last example, x squared minus 4x plus 7, all divided by x cubed minus x squared plus x plus 3. So when we had an example like this with 4 terms in the denominator, we attempted to group them. So if I factored out an x squared from the first two terms, I would be left with x plus 1. But there's nothing I can factor out of the x plus 3 in order to make it factorable. So if you recall way back when, to check to see if something's factorable, we take the ratio of the factors of the constant term to the coefficient of the degree term. So I'm going to check to see if positive negative 1, positive or negative 3 are factors of this denominator. And you did that using synthetic division. So to see if 1 is a root, I put my coefficients in order. Bring down the 1. 1 times 1 is 1. Negative 1 plus 1 is 0. 1 times 0 is 0. I add that column. 1 times 1 is 1. When I add that, I don't get a remainder of 0. So that won't work for us. Let me check negative 1. 1. Negative 1 times 1 is negative 1. Negative 1 plus negative 1 is negative 2. Multiply, add, multiply, add. So since I got a remainder of 0, that tells me x equals negative 1 is a root or a solution, which means x plus 1 is a factor. And then these are the coefficients to the remaining factor. So it always drops in degree. So 1x squared minus 2x plus 3. So now I have x squared minus 4x plus 7, all divided by x plus 1 times x squared minus 2x plus 3. So now I can set up my partial fractions because I have my denominator in factored form. So one linear factor, x plus 1, one quadratic factor, so bx plus c, all over x squared minus 2x plus 3. All right, multiplying by our common denominator. And my equation becomes x squared minus 4x plus 7 equals a times my quadratic plus bx plus c times x plus 1. All right, so I'm going to run out of room here, so I just rewrote it here. Now you can use the method of equating coefficients if you were to multiply the bx plus c times the x plus 1. But because we have a linear factor, we have a 0 of this factor. So let's substitute in some numbers. So I'm first going to make x equal to negative 1. Then I get 1 plus 4 is 5. So I get 12 equals a times 1 plus 2 is 3. 3 and 3 is 6, and then it completely cancels out that last term because we made x is equal to negative 1. So I have a value for a. A is equal to 2. Next, let's replace x with 0. So I get 7 equals 3a plus, this becomes 0 plus c, so c times 1 gives me c. Substituting in the value for a that we found, 1 is equal to c. So now lastly, to find b, we can really pick any other value for x. So pretty easy to substitute 1. 1 minus 4 is negative 3 plus 7 would give me 4 equals, my value of a is 2. 1 minus 2 is negative 1 plus 3 is 2. B times 1, that would give me b plus c, and then times 1 plus 1. So I get 4 equals 4. Plus 2b plus 2. And then I get 2 equals 2b. Wait. Hold on. Looking in two different places. Sorry about that. So I get 4 equals 6 plus 2b. Negative 2 equals 2b. So I get a value of negative 1 for b. So now let's go back and we plug it into our original. So I get the antiderivative of a. So 2 over x plus 1 dx plus bx. So negative x plus c all divided by x squared minus 2x plus 3. And we should be replacing c with 1. So this is what our decomposition looks like. All right. U, let's look for a U substitution here. So du will equal 2x minus 2. Now notice what I have here already. So if I think about factoring out a negative 2, that would give me negative x plus 1 dx. Okay, so a U substitution will work here as well. So I'm going to put my negative 1/2 out front here. This 2 times the natural log of the absolute value of x plus 1, that's my log rule, minus 1/2, log rule again, natural log, absolute value of x squared minus 2x plus 3, and then all plus c. So that's our final answer. No additional homework for this section.